In this video, let me consider the cascade realization of the given system. Obtain cascade realization of the system h of z is equal to 2z inverse minus z power minus 2, z inverse minus z power minus 2. So we know that in cascade realization, the system h of z is divided into subsystems. Let this be the subsystem. I will call it as h1 of z, and this is another subsystem, that is h2 of z. So in cascade realization, these two subsystems are connected in series or cascaded like this. So assume that this is h1 of z, and here we have h2 of z. These two systems are connected in series, that is cascaded. The input here is say x of z, and the output here is say y of z. So these two blocks together is nothing but h of z. Now let me assume input to this h1 of z is x of z, and output of h1 of z is, I will call it as w of z, and output of input to h2 of z is w of z, and output of h2 of z is y of z. So to system h of z, x of z is input, y of z is output. That is, here these two blocks together is nothing but h of z. So first let me consider h1 of z. So I can write h1 of z is equal to, the output of h1 of z is w of z, input is x of z. Let me write that w of z divided by x of z, which is equal to, here we have assumed this function as h1 of z. So h1 of z is 2z inverse, we have minus z power minus 2. Let me simplify this. Therefore I can write it as w of z is equal to, I will send this x of z on other side, that is 2z inverse minus z power minus 2. We have x of z, or w of z is equal to 2z inverse x of z minus z power minus 2 x of z. Now let me take inverse z transform of this, that is taking inverse z transform of above equation. So I can write inverse z transform of w of z is w of n is equal to inverse z transform of z inverse x of z is 2 x of n minus 1, that is shifting property of z transform, minus here we have x of n minus 2. Let me call this as equation 1. So now let me consider the another system, that is h2 of z. h2 of z is nothing but z inverse minus z power minus 2. So input to this block is w of z, output is y of z. So therefore now let me write h2 of z is equal to, that is system function is equal to output by input. So here output is y of z, input is w of z. Y of z divided by w of z, which is equal to, we have z inverse minus z power minus 2. Z inverse minus z power minus 2. Simplifying this, that is y of z is equal to z inverse minus z power minus 2. We have w of z, or y of z is equal to z inverse wz minus z power minus 2 wz. Now by taking inverse z transform again, now taking inverse z transform of above equation, we get y of n is equal to, this is z inverse w of z, its inverse z transform is w of n minus 1 minus, here we have w of n minus 2. Let me call it as equation 2. Now we'll realize these two equations. Now let me write these two equations here. That is W of n is equal to 2x of n minus 1 minus x of n minus 2. This is first equation. Second equation is y of n is equal to W of n minus 1 minus W of n minus 2. This is equation 2. Now I will try to realize the first equation, that is, so let this be x of n. Here we can see that 2x of n minus 1. So we should, to get x of n minus 1, we should pass x of n through delay element, that is z inverse. This is z inverse. The output available here is x of n minus 1. So here the scaling factor, that is multiplied with 2, that should be shown like this. So here the signal is 2x of n minus 1. It should be added with x of n minus 2. So here it is x of n minus 1 passed through another delay element, that is z minus 1. Here output available is now x of n minus 2. That should be multiplied with, here coefficient of x of n minus 2 is minus 1. So it should be multiplied with minus 1. So these two signal will be added up. This is added with this signal. So this output at this point is nothing but W of n. So let this be W of n. So now let me concentrate on equation 2. Here we have y of n is equal to W of n minus 1 minus W of n minus 2. Here W of n minus 1, W of n is available. It should be passed through another delay element. So I will pass through delay element. So output here available is W of n minus 1. Here the coefficient is 1. So it is 1. Say this is 1 minus W of n minus 2. So pass through another delay element. So output of this is W of n minus 2. It should be multiplied with minus 1. So it is minus 1. So this signal and this signal should be added. Take one adder here. So now this is the output y of n. So this is the cascade realization for the given system. So now here we can observe that this is the first system, that is h1 of z, and this is h2 of z. Thank you for watching.